Here, Chiara at the back.
No.
So I don't think the mute is on.
Would you know how to? Is this better? No.
It's working. You might just have to put it more central.
More central.
Yeah.
Okay. You let me know if it doesn't work. So yeah, I mean, I just kind of went through my notes and to the discussions that emerged after my presentation last week, and again there were a lot of questions that were quite specifically about narrative theory, and these are some of the canonical texts on the topic. So especially the first one, Time and Narrative from Paul Ricoeur, is very important. The open work is something we spoke about last week, Biography of the Object likewise, the content of the form as well. And then this short essay from Lorraine Doston, which is at the bottom, it kind of addresses the question about the role of the humanities and the role of narrative story making within the humanities and its relationship to STEM. But yeah, so before we go into today's lecture, I kind of wanted to quickly summarize what we spoke about last week. So last week we spoke about the role of narrative in representing complex phenomena like climate change. And we spoke about the fact that even though stories feel very, very compelling to humans and make a lot of sense to us, it might not be the case that they are the most adequate sort of mode of representation of complex phenomena like climate change. But all in all, we were not trying to say whether narrative is good or bad, just how adequate it is, and most importantly, that it is not the only only mode of representation. And we hope that we kind of mapped the territory for alternative modes of representation. But a lot of remarks and a lot of questions were kind of siding more with team narratives. And there are many good reasons for this counter argument. So narratives are a pretty good technology, many reasons. They allow us to make sense of very complex topics that we otherwise would not be able to understand. They offer some kind of meaning. They offer some kind of goal. And sometimes they are a good way to represent things. And there was another question that I thought very important, and that in many ways kind of leads to today's talk, that was about essentially the role of models in general and climate models specifically, the role that they have in coding quote from this person, biases, and how narrative is just one form of kind of introducing a certain filter on reality, but models themselves already have this kind of filters. And so today, what I want to do is to bring forth a case study about the very first two world models. And what I mean by that is that these two world models that I'm going to talk about now first emerged in the 1970s, in the early 1970s. They are computer models, so they're able to simulate and forecast certain variables as they will happen decades later. Before the 70s, we were able to forecast the weather. There was data about the weather. Short-term forecasts were fine, but we did not have the technology to do long-term or medium or long-term predictions. And nor there was a political will to do that, because at that point, most predictions were kind of statewide, and they were kind of region focused. But after the 60s and the Cold War, and I mean the 70s are still the Cold War, there is this kind of transnational interest in understanding how to compute things and variables that happen to the planet at once. And so there were these efforts within the scientific community to think about the planet as one unit and to create tools and conceptual and technological tools to allow us to calculate these variables. So what you're seeing on your left is the Limits to Growth report, which is a book. It's one of the best-selling environmental books ever. It came out in 1972, and it was published by the Club of Rome, which is an organization that was started in Rome. We will get into that. And it uses a model that kind of predicts the, quote, predicament of mankind. And what I argue is that the limits to growth is in many ways the ancestor of the climate models that we have today. On the other side, we have this other report that's called Catastrophe for New Society, a Latin American world model, which came out 2 years after, actually 4 years after it was published in 1976. And it is the most important critical response to the limits to growth. So a lot of scientists that had a problem with the limits to growth approach, which we will go into, decided to come together and draft another report. And they did so. And they used a radically different method to do that. And the striking thing about the limits, the Latin American world model, the green one, is that there isn't much research that's been done about it. That's what I would like to do. And that's what I'm doing, that's what I'm trying to do. And I would like to share some of the research that I've done on this topic today. So there are two main questions that we will try to answer today. And one is why and how did catastrophic techno-economic projections win the struggle for climate models and therefore planetary imagination? And then the second one is how and when did the political and utopian models lose this battle? So there are a few assumptions here. I guess the first question refers more to the limits to growth. We will see how it is in many ways very catastrophe-oriented, extrapolative, and sort of merely descriptive of a state, and it's not in many ways ideological or political, whereas the Latin American world model claims in many ways to be political. So now, just a second. So the story of the Limits to Growth report and the Latin American world model is somewhat a quite straightforward parallel story of two teams of scientists working on two different models. But this is a very complex subject. And so, yeah, I mean, it's going to be a little bit tricky, but let's try and understand what the object of inquiry of what climate models today are. Let's try and understand what as well as we can today. So this graph that you see here is what today we call integrated assessment models. So these models are the dominant contemporary genre of global models. They combine representations of the economy with those of environmental systems in order to explore adaptation and mitigation scenarios. So we briefly looked at these models last week, but we want to take a little bit of a closer look at these models. We will only briefly define what they are, just to an extent that can help us read that history. And just to the extent that we want to understand what the role of models is in prediction of the planet's futures today. So these models are often used as the pathways that towards which politicians make decisions and base their policies. These kinds of knowledge is produced by bodies like the International Panel for Climate Change, and they're used to produce climate projections and policies and things like that. This is part of what historian Paul Edwards in this book, which is also great, call knowledge infrastructures. So knowledge infrastructure are robust networks of people, artifacts, and institutions that generate, share, and maintain specific knowledge about the humans and the natural world. So he argues that just like there are sewers and roads and trains and kind of normal brick and mortar infrastructure, there are also things that are called knowledge infrastructures, like this monstrous graphs over here. They are created through a very robust network of scientists all over the world that work very hard every 2 years to kind of produce these projections. And there are infrastructures because their knowledge is codified, they're durable, they're predictable. So the main three things that we want to remember about climate models today and integrated assessment models today is this: they are the dominant genre of climate modeling. So there are many different ways that we could model the climate. These are the dominant ones. These are the ones that the IPCC uses, that governments use. These are the ones that is kind of like the current scientific paradigm, right? So there is no much kind of epistemic diversity there. When the scientific community comes to a consensus, this is what we have. The second thing is that they are synthetic measures in the way that they are interdisciplinary, so they combine very hard math and like kind of geophysical questions and data about the Earth with the social sciences. So they combine human decision making and politics and ideologies with temperature, CO2, and things like that. And the third thing you want to keep in mind is that they're descriptive. So they don't claim to be predictions, they don't claim to be recommendations, they don't claim to be warnings, they claim to be projections. And projections are merely descriptive of what scientists think is likely to happen. So in that way, they're very depoliticized and kind of agnostic as to what should be happening in the future, or so they claim. So why looking at these two models specifically? I think this is perhaps the most important moment in history to understand why did we end up with this kind of three characteristics of the models that we have today. This is a moment that in many ways we see some like a forking path between the more kind of techno-economic, descriptive, agnostic way to see the world, which is the limits to growth, and the more ideological, political, and maybe utopian way to see the world, which is the model that the Latin American world model was proposing, but that we did not get for one reason or the other. So this is the introduction to the Latin American world model. And when I first came across it, I never heard about this model. I just read a very short essay, I think on the Scottish blog for global history or something like that. So then I looked into this document and I read this sentence that I'm going to read out loud. Any long-term forecast of the state of humanity is founded on a perception of the world that incorporates a system of values and a concrete ideology. Seems pretty straightforward and pretty, I mean, I guess most people would agree in this room that this is broadly true. But in the 1970s, there was a whole group of people who really felt that this needed to be said, and I still feel like this needs to be said in certain scientific contexts and policy contexts. So, like I said, this is kind of I've gone to the archives. I've gone to the Club of Rome archives in a small town close to Rome, and I've visited some other archives. I've done some interviews. So this is kind of a first way to present the research that I've come up with, which is now in a form of a draft of a paper that will be published. And I'm going to share some of it with you, and I hope this will make good basis for a discussion later. So the way that I'm going to present this paper will go a little bit like this. So first, I will introduce the current critiques of integrated assessment model of climate models today that we are having. And I will try and answer this question. So what do we think are the problems with contemporary world models, and what are our frames of reference to discuss these problems? And then I will try and make a case based on two ideas. One is that these conversations that we're having today, these critiques that we're having today, are not new. We already had these conversations when world models had first emerged in the early 1970s. And the other idea is that if we can be bothered to look at these conversations, that we might look at current debates with a fresh perspective and maybe reinvigorate these conversations that we're having today. So first, this will happen, and then I will tell you 3 interlocking stories. They're all set in the 1970s, and they're all around the emergent world modeling. So I will talk about 3 short historical fragments and 3 short stories. So yeah, let's get to the story itself. Yes, but let's start with the critiques of world models today. So there are 3. I've identified 3 strains of critiques of the climate models. So let's call them climate models today. The first one is around questions of justice and ethical concerns. So there is a lot of literature that says that basically, although these models claim to be techno-economic and therefore not designed to deal with questions of justice, they do end up dealing with questions of justice, because they basically portray a sort of a limited set of feasible futures, and this limited set of futures informs policymaking, and therefore it's important, according to these researchers, to ask who speaks for different climate futures, or who bears the benefit and burdens of the impact and responses to climate change. Then there is a second strain of critiques that is around questions of epistemic lenses and access to production. So last year there was, among many other kind of things like this interview with an IPCC scientist that claimed that climate models today are quite Eurocentric or Western-centric, and the access to knowledge production in this context is kind of limited to scientists that come or live or operate within the West. And so there are certain epistemic barriers to the making of these models. And then the third line of critique is arranged around the concept of performativity, which is understood as the constructing and influencing of reality by models that don't simply, so models, the idea of performativity is that models do not simply describe reality, but even if they just claim to describe reality, they inevitably performatively make some of this reality. And so because this happens, there is no such thing as a purely techno-economic document. Now, let's go to the limits to growth. So how are these contemporary critiques related to the limits to growth and to this story, this history in the 70s that I've hinted at? So contemporary global models are not the first ones to bring together all environmental, economic, and societal concerns in order to produce simulations of what different future scenarios might look like. They are part of this much longer tradition of global computer modeling that emerged in the early 1970s. And the most important ancestor of contemporary climate models is the model behind the Limits to Growth report, which is based upon MIT engineer Jay Forrester and his work on system dynamic, which system dynamic was originally designed to model industry processes. So it was initially designed to be used within industry or within corporation, and then it was expanded to be used within cities. And an interesting fact is that Forrester's model was used to model SimCity video games as well. But also just to kind of simulate a lot of actual cities in America. And then he somehow managed to apply system dynamics to the first world model. And so let's go into this first world model. So this is a graph from the Limits to Growth World Tree model. And I mean, one thing that's worth noticing immediately is that contemporary world climate models do not look like this. There is no variable that's called pollution, or population is not modeled that way. Natural resources are. It's much more granular. It's much more precise, and also our kind of framing of these problems has changed in many important ways. But what I wanted to say quickly is that comparing the Limits to Growth report and World 3 to the Latin American world model is a very, very tricky project for many reasons. So the Limits to Growth has been extensively documented. There are books and books and books about this. It's been a best-selling book. Everything and anything has been written about this. Whereas the Latin American world model has received no attention. So a fair comparison between the two is not possible. And also making this comparison is not really the aim of this. So South American academic research projects in the 1970s, especially those with a socialist agenda, were consistently disrupted by coups and the installation of violent far-right regimes that targeted many of the ongoing academic and scientific projects, often forcing academics to relocate. And those affiliated with the Latin American world model were no exception. And also, there is plenty of primary resources. There is an archive that's just been put together in Buenos Aires. There are still scientists that worked on this project that are alive, just haven't been able to interview them yet. So let's go into the first story, the first historical fragment, as I promised. And it is, we are in between 1969 and 1971 at the Club of Rome, where we're witnessing the struggle for this first world model between Jay Forrester, who is the MIT scientist that I just spoke about a moment ago, and Hasan Özbekan, who is a Turkish in-house cybernetician of the Club of Rome. And now we will see why this struggle matters. So this is Aurelio Peccei, which is the founder of the Club of Rome. He is the ideational leader behind the Limits to Growth report. So his goal was very ambitious, was to analyze the predicament of mankind. So he was working as an industry man for Fiat, and after spending over a decade in Argentina while leading the South American divisions of Fiat, the automotive company in Italy, he grew very preoccupied with environmental degradation, overpopulation, and inequalities, which he understood to be driven by processes of industrialization. So he was in Latin America and he saw industrialization happening, and he grew very preoccupied by seeing this kind of degradation and overpopulation in his eyes, this perceived kind of degradation of the environment. And so he wanted to work on these long-term predictions of mankind. So Peccei understood that in order to analyze these interconnected and complex links between social, economic, and environmental systems, he needed to build new conceptual and technological tools. So he set out to represent and simulate the world's resources and ecological states for decades to come, as well as the impact that different policies would have on the environment via the, quote, systematic use of global models. This represented a major innovation, since never before had mathematical models been used to describe human society in its total environment as an overall system whose behavior can actually be simulated and studied. So this was a huge kind of rupture with the past. So this struggle that was ongoing internally at the Club of Rome in those early years, where Peccei with his team of scientists and cyberneticians, as they were called at that moment, the struggle was between a sense of urgency to model the world as one thing and one unit, and the kind of methodological precision that was needed to do something so big, such a big project. So they embarked on this conceptual journey to find the right modeling tools for this project. But Peccei was concerned about the methodological soundness just as much as he was about gathering corporate support and quickly publishing the result. So Peccei, as an industry man, approached the Volkswagen Foundation, which at the time was interested in sponsoring this project. But the Volkswagen Foundation only wanted to sponsor this project if it would happen quickly within a year, and if it would be a best-selling, if it would be a hit. So they wanted to have a project that worked with current tools. They didn't want to waste time, and they were less concerned about the precision of the project. And this clashed with the in-house cybernetician Hasan Özbekan. So he wanted to, he required 15 months to design this completely new methodology that would allow the Club of Rome to model the planet as one. And in this 15 months, he didn't even promise to deliver a clear-cut tool, but rather a method to get that tool. So it was an incredibly vague promise that Volkswagen Foundation did not like. So what happened, sorry, is that in the summer of 1970, after a lot of heated meetings, members of the Club of Rome were almost giving up on this project. It was too complex. It took too many resources. The methodology was unclear. It seemed impossible to carry this out. And in one of these meetings, Jay Forrester, the MIT cybernetician that worked on system dynamics, showed up. Deus ex machina, as some of the people were there describe him. And he suggested that he would use his systems dynamics method to kind of design this new world modeling tool. And the Volkswagen Foundation liked it because this method already existed. It was kind of off-the-shelf tool. They didn't have to invest to do a lot of methodological innovation. They didn't need to sort of invest a lot of money and time and resources in this, so they went with that. So yeah, Peçey liked the kind of Turkish cybernetician Hasan Özbekan's approach, but he thought that despite being in principle reasonable, he was very concerned about the length of the project. Anyway, in 1971, the first preliminary results of the Limits to Growth report were of the World Tree model, this model designed by Jay Forrester, were run on the Club of Rome computers, and as it turned out, the results were catastrophic. In less than 100 years, all of these variables would collapse. They found out that population growth and kind of economic growth would lead to total collapse, and that we were doomed essentially. And this made the first pages of a lot of magazines. At first, there were some strong reactions saying, "Oh, this is not true." But this document, in many ways, was one of the most important kind of data that backed the environmental movement throughout the 70s and 80s, and still today. There's a lot of references of the environmental movements to the limits to growth. And more importantly, a lot of the methodological assumptions that were used in this model are still alive and well in the models that we use today. So at this point, we are in 1971. The Limits to Growth report has not been published yet, but the first simulation has been run. Just taking a step back. So the first simulation has been run. We're in 1971, and it's been presented in several universities across the globe. One of them is in Rio de Janeiro, where the Argentinian scientists that would then produce the Limits to Growth report were also present. So let's go. I mean, we can reflect for a second and analyze like what are some questions that this story might kind of make us ask. And one is how funding agendas shape the content and trajectory of climate research. Of course, having the Volkswagen Foundation and a man who was in charge of an automotive company in Italy probably does shape the kind of work that's been done, and how scientific controversies emerge, evolve, and are resolved, and also the media reception to Limits to Growth. But let's move forward to this second episode, which is the design and development of the Latin American world model from 1971 to 1974. So when the Club of Rome presented the preliminary results of the World Tree study at the Candido Mendes University in Rio de Janeiro in July 1971, Carlos Malman, who was the director of the Bariloche, which was imagine it as an Argentinian Club of Rome. So it was a it was a small group of scientists in a small village in the Andes in Argentina, who gathered enough resources and support to do their own scientific and social sciences and cybernetics research. And that's what they were doing. Carlos Malman was the founder, and he was sitting at the conference where the Club of Rome presented the preliminary results of the World Tree study. There were many strong discussions that followed the presentation of the World Tree models, the Club of Rome models. And during these heated discussions, many Latin American researchers expressed strong criticism of this Forrester model. The Club of Rome's findings were suggested the only way to stop environmental degradation and societal collapse was for the developing nations to stop growing. So the Bariloche scientists thought that the limits to growth report was a deeply unfair and neo-Malthusian stance. Malthus was famously someone who was very concerned about population, and that kind of predicted the collapse of several systems based on population growth. So neo-Malthusian refers to this newly found interest in Malthus that we see across the 70s. So being scared of too many people being alive or being born, or just too many people in general. And the Global South, what we now call the Global South, did not like this. But more importantly, what they thought is that the model was rife with statistical and methodological errors. So not only was neo-Malthusian and dystopian and catastrophic, it was wrong. They argued that the Latin American scientists, the Argentinian scientists, argued that it was wrong. So in light of this strong criticism that emerged in Rio, Aurelio Pecei, the Club of Rome founder, commissioned the Bariloche Foundation to put together a feasibility study that would help scientists formulate an alternative world model to the limits to growth study. And so from 1971 until 1974, Amilcar Herrera led a group of 19 interdisciplinary scientists in designing the Latin American world model. There were several important differences between the Latin American world model and the limits to growth. Just to cite a few, the Latin American world model modeled the population as an endogenous variable, so that evolving societal conditions would influence demographic growth, and therefore higher living standards would result in lower population growth. So contrary to the limits to growth that modeled population as an exogenous variable, the model is an endogenous variable, which means that if there are higher living standards, there are less people. The Bariloche model also formulated for the first time the concept of basic human needs and translated them into quantifiable and achievable goals. The Latin American world model overall, they modeled different regions separately instead of the planet together, and they were interconnected in a more sophisticated way. But the most important argument that the Latin American world model put forth was that the limits to growth report approach focused less on an added variable and more on the overarching opposition to the proclaimed value neutrality World Tree, which in Pecei's word was meant to purely describe of a situation as it already exists today, and of the possible outcomes that if present trends continues. So again, like the most important difference was this ideological difference on whether models are normative, always in character, or if they can just be descriptive. So let's go to the third and final historical moment in this story. That happens between 1974 and 1978. And this is about the presentation of different world models that happens at this place that you see in the picture at the time. That's the International Institute for Applied System Analysis in Baden, Austria. And this is an institute that was founded in the 70s to allow scientists from the East and West to collaborate. And here is where a lot of different world models, there was a first conference on world models that happened here, where the Latin American world model scientists presented their model, and the Limits to Growth, the Club of Rome, presented their own model. This was in October 1974. So one of the scientists present at this conference wrote about the model, and he was kind of shocked. He wrote that, quote, "They could have plugged in any objective function," the Latin American world model, "they could have plugged in any objective function into the model at the whim of anyone in the audience. We were even asked if we had any preferences," end quote. The Latin American world model received thorough critique also from Nobel Prize winner Wilhelm Nordhaus, who was there at this conference. In his memo, he writes that, quote, "With close attention to the problem of techniques and methodology, the Latin American world model is an incomplete model, one that cannot at present be taken terribly seriously as a normative or descriptive model of the world economy, but nevertheless, it represents a significant improvement over the Limits to Growth model." So it's kind of interesting that one of the most prominent economists said that the Latin American world model was already like a much better model than the Limits to Growth, but that didn't really seem to matter that much for the international scientific community. 2 years after that presentation, the Latin American world model was published under the title Catastrophe for New Society, with generous funding from the Ford Foundation and from the Canadian International Development Research Center. And it was translated into 6 languages. But the Spanish edition, however, only appeared in 1977. The delay was due to another coup by far-right general Jorge Rafael Videla, which marked the beginning of over a decade of persecution, disappearances, and killing of leftists and political dissidents. The regime was backed by the American government, and ironically was also backed by Ford Motor, which was funding the development of this model. And Ford asked his managers to report all of the leftists to their factories, and they were persecuted. And this also led to the persecution of the Bariloche scientists, who could not finish their work and could not complete their work, and they're now living in all different countries. So I would like to just conclude by saying that I hope that this kind of gives us an idea of these historical contingencies that shaped the climate models that we have today, and that we kind of learned something about how knowledge is made, and how knowledge about the planet gets made today, and what its roots are, and to understand that yes, of course, climate models are a very scientific topic, but there's a lot of there are a lot of narrative elements to them, and there are a lot of sort of historical elements that have helped influencing what they are. And I hope that we can kind of mature a bit of that sensibility, because I think it's a very important topic. Okay, thank you.